system.
See how strong your Wi-Fi is.
That's right. All right, we can see that, correct? All right. And then we're in different spots, I think, Mr. Kubowitz. So you guys at home,
I think we got farther in third period.
So are we just on number one? If you guys can look at your notes at home, did we just get number one done? Or did we get into number?
We're on 2 right now.
Have we done 2? We haven't done 2 yet?
No, we haven't.
Okay, then let's go down to number 2. I thought that's what we were at. It'll be good anyway to do this little review. It's probably good to have this one left over because then we're going to do the opposite. So what we've been doing is finding the area of this by multiplying these guys together. And then we can write the area equation. What's going to happen in a minute, you're going to be given the area equation, and then using that, we've got to fill in our rectangle, all right, with what dimensions they would have. All right, so good little review here, I guess, to lead into those next set of problems. All right, let's try this. I know. All right, so it says label the given rectangles with the dimensions of 2x plus 1 and then 2x plus a 5. So notice in both of these, those first terms are the same. And right now, the reason those are the same is because rectangle number 1, the small one, notice how that's a square. Each side has the same length. If we just kind of visually looked at it, that is intended to show that each side is the same, and each side is going to be the 2x. And then the first one, we're just going to tack on an additional 1. So if this was our original length, we'll call this the 1 since it's the smaller. So we're going to increase that side by a 1. And then the longer side, we're going to increase by 5. So this is our longer side. So we're going to say that that is a 5. So if we added the left-hand side up here, that's a 2x increase by 1. The bottom is a 2x increase by 5, just like we should have up here. Now all we're going to do is find the areas of each of those. So with each of these, all we're really doing is your base times your height or your length times your width, whichever you think. So for this first rectangle, we call this one the Roman numeral number 1. That is 4x squared. If we did 2x times a 2x, that should give us 4x squared. If we come to this one, that's a 5 multiplied by the 2x by this height here. So the 5 and the 2x here should be giving us a 10x. This base up here is 2x, and the height is a 1. So if we did this 2x and a 1, we should just get 2x. And then upper right-hand corner, this has a base of the 5 below it, and a height of the 1 over here on the left. So the 5 and the 1 should make 5. So our overall area, let's add these up, are all 4 of those added together. So you're going to have a 4x squared, and we want to put these in this correct order, in that descending order, and then plus the 2x, plus a 10x, plus a 5. So what I want you to notice so that we can transition to these next couple of problems here in a minute, notice how what we're adding together are the 2x and the 10x. That just so happens to be this diagonal. I think we did talk about this briefly yesterday. Those are the ones that we're always adding up. If you went back and looked at the previous couple of problems, the 2 in the upper left and bottom right-hand corner, those end up always being your like terms, so that in this next step, we would get a 12x and then plus a 5. What you also now want to recognize when we get to these next problems, this upper right-hand corner is always your constant. Notice how there's not a variable there, it's just a 5. If you were to revisit the previous couple of problems, same exact thing. You wouldn't see a variable there, it's always our constant value. And then down here, this is always our square. So this is our area. The other way we said that we can do that, and that's what we're going to be doing also here today, is just take the overall base, so the 2x plus a 5, that's the big base, and multiply it by your height, which is the 2x plus a 1. If we FOIL that out, we better get the exact same thing we got when we added everything up. So that's what we'll do real quick. So 2x and 2x would give us that 4 and then the x squared. The 2x and the 1 would give us a 2x. The 5 and the 2x give us a 10x. and then the 5 and the 1 give us 5. So if you look at what we just got, here, it's the same thing that we got when we added all those terms up individually. You would then just combine your like terms like we also did, and it should give us the same answer. All right. All right. So now we've done a number of these. Now, like I hinted at here in a minute ago, we're going to do the opposite. So what you're going to see in number 3 is I give you the area equation. And with that, we're going to fill in these values. All right, so it says if you're given the entire area of the largest rectangle, can you label the dimensions of the rectangles themselves? So there's really a couple different ways. We could try and figure out what goes inside of here and then use what goes inside of here to figure out our dimensions. You could go right to figuring out what the dimensions are. So if you remember, this was our A, B, I think we called that, no we didn't. We called this A, this was B, and this C, D. That's not important right now what the variables are, but those are what we're trying to find. What are each of those lengths there? All right, so see if you can, see what you can come up with here. All right, see if we could even get this started. Okay, I would hope 2 of the 4 we would think is pretty simple, hopefully, maybe. So let me get rid of these. And the 2 of the 4 that I hope we could get would be this one and that one, if we're just going to fill in the areas within those rectangles. All right. Anybody want to throw something out there? Any thoughts? Yeah, Cam, go ahead.
Oh, the one in the bottom left is going to be x squared.
Good. And why'd you come up with that?
Because you just told us a second ago that the box in the bottom left is always going to be the square.
Good. And to more of that point, see how this is just an x squared? What that tells us is that we had just an x here and just an x there. So that when we multiply those together, we would then get this x squared term that starts that area formula off. All right, good. All right, Cameron, you got something else? Or Nora. I went back, I have Cameron next period. You guys sat by each other all the time, and I just called you Cameron. All right, so Nora, what do you got?
For the top left square, I got either it could be 2x or 9x.
So which one would you want me to put?
I put 2x.
And then where did you put the 9x on the other?
Yeah.
Okay, good.
Top,
To me,
right.
good. And to me, those are probably the harder ones. So I'm curious how you're going to explain you got that right off the bat. Did you get that first, or did you get something else first?
I did those ones, like I did the x squared first, and then I kind of just went with it from that because I was trying to figure out how you would get the 11x. So then I just did that with the 18 also kind of.
Okay. And then, so what went right here then, Nora?
18.
Good. So this had to be our 18. So I would have thought the 2 that I had in yellow, hopefully we could get those. That whatever the squared term is, like Cam told us a minute ago. So this guy, even though I just covered it up, that's got to be the lower left-hand box, if we've noticed that little pattern. And then whatever this constant value is, that's got to be the upper right-hand box. But then kind of what Nora is saying, I think, when she said, how could I get an 11? When we went back up here, see how we got 12x? And the way we got that 12x is by adding the 2x and the 10. We basically added these guys together. So they had to add up to be that middle term. I hurry up and did this real quick. You guys have it in your work. But the answer to number 1 that we had gotten yesterday, notice again how the leading term is our squared term. Eventually it'll show up. That happened to be this lower left-hand box. The constant value was this guy. And then notice how if we added these guys together, doesn't that add up to be the middle term? So now the question for Nora real quick, because let's now determine how we got specifically 11, because wouldn't like 6x and 5x also add up to be this 11?
Yeah, I looked at the 18 too, so I kind of did the 18 one first.
Okay.
Figured like from there how I could get 11.
Good. Because now we're getting there to where I would think too, we probably want to do that 18 first, because not only do we need to get this value right here, which had to have been a 9, and this value here to multiply to be an 18, but they also better add up to be this middle term. And a 2x and a 9x add up to be the middle term here, but when we multiply those together, you're also going to get that 18. All right, good. Thanks, Cam and Nora. All right, see if that made any sense. Try letter B now. See if that makes any sense. If you weren't sure of the first one, now that we've worked through B, see if we can get what you think B would be. Okay, anybody think they have this? All right, and then my grid view is not working, so I only see about 8 of you right now. So if somebody else has their hand up, sorry, but I do see Cam. So go, Cam. What do you think?
So for the, I'm gonna give you the top left and the bottom right.
Okay.
So I have 5x in the top left and then 8x in the bottom right.
And why'd you pick that?
Because if you add those two together, you get 13.
Good. So we said if we add these together, you're going to get 13. And then what else?
And then if you multiply 8 times 5, you get 40 for the top right.
Good. And then if we multiply them together, it's going to give us the constant value of 40. So it satisfies both of the things that we've had to been able to satisfy in those previous handful of questions. Okay. And then the left-hand corner is easy, right, Cam? Lower left?
Yep.
All right, that's
X
what?
squared.
Good. So now let's label this. This would have just been x. This would have just been x. So if this now, the lower right-hand corner here, was 8x, that meant this had to have been an 8. And if this is 5x, and here's the x down here, this had to be a 5. All right. So now, before we move backwards, let's rewrite this area equation into kind of the unsimplified version. Wouldn't this have to be x plus 2? And then this down here would have been the original x increased by 9, if we think backwards. The same thing with this one. If we were to work this one backwards, didn't we have an x? And then we added an additional 5 units on top of that. And then we would have an x on the bottom. and that increased by 8 on the bottom. All right, so this is our kind of what we're going to call a factored version. This is very much what we're leading up into, all right, in the next couple of days, is what if we are given this, could I actually go backwards and factor that out? All right. Okay, good. Now, the next ones, we just need to do a handful because we've done this to some extent already, where you're going to be multiplying these polynomials, combining their like terms. So, actually, do number 4. We should be able to do this. I really want to be able to get to 6 and 7. And we'll probably just do number 4. We might skip number 5. So we can start seeing some little shortcuts here, some little special things. Do number 4. My phone is obviously blowing up, you can probably hear. All right, and Nico, I can see you, Nico. What do we do here, Nico?
So you're gonna multiply x by times x.
Good.
And then x times -12.
Good. So the x gets distributed. Should give us that. And then we do what, Nico?
And then you're going to multiply 11 by x.
Good.
And then 11 by 12.
Good. And 11 by 12. I think that's 132 if I remember correctly, hopefully. All right. And then we have some like terms like we talked about. Just like we've had in all those problems, we're going to combine those. The -12, +11 is a -1. All right. And then that's our simplified area. All right. All right. So now what I want you to do, just make sure we get through enough of these. Jump down to number 6. And what I want you to recognize about number 6 first. Up here, they both had the same first term. So notice how the first terms were the same, but the second terms were definitely different. All right. So what you're going to look at in number 6, the first terms are the same. They're both A's. The second terms are largely the same. They're both a 10, correct? Except one's a minus sign and then one's a plus sign. So the first terms are the same. The last terms are the same. And then you have a sum, you have a difference. See how that plays out. Multiply that out and see what we get. So what Nico just walked us through, go ahead and now do with this one. Nothing crazy, but something interesting should happen here. When you simplify this, something nice should happen. So let's see what you got here. If we go ahead and distribute, like he walked us through, a times a will be an a squared. That a times the 10 is 10a. The -10 would now get distributed, so a -10 times a is a -10a, and the -10 times a +10 is a -100. When we now go to add like terms, notice how we have a +10a here, and then we're going to take away 10a. What we hopefully then understand is those cancel each other out. So that and this are just going to go away, and all we end up with is a -100. So our final answer then simplified is a squared minus 100. So one of the things we'll prep right now, we'll talk about in due time here. This is what is called a difference. And it's a difference of two perfect squares. That's an a squared, and then notice how 100 is a perfect square of 10 if I square 10. So this is what we would call a difference of squares. And when we look back at what that meant our first terms were the same, our second terms were the same. One was a difference, one was a minus, or one was a plus. All right, so jump down to number 8 real quick so that we just recognize this little pattern here. We prepare for what you're going to get into here in the next few days. Notice how first term is the same. They're both 2x's. The last terms are the same. They're both 3's. And then just like that previous one is a minus sign, one is a plus sign. So something very similar should happen that just happened in that previous problem. All right, so do it, see if that's how it plays out. All right, and then hopefully something similar happened here. When we do our 2x times a 2x, that's a 4x, and then the squared. The 2x and the negative 3, negative 6x. Then we take our 3 and distribute, we'll get a positive 6x, and then the 3 and negative 3 make a negative 9. So what should have happened, and this happens all the time when we're talking about the first terms being the same, second terms being the same, one's a sum, one's a difference, these guys cancel each other out. You get a positive 6, you get a negative 6. If we combine those, they're going to cancel. And what we really just get is a 4x squared minus a 9. So this, again, what we would call a difference, because we're subtracting. Oops, I didn't want that. And then of 2 perfect squares. 9 is a perfect square, and then 4x squared is a perfect square. All right. You'll hear that a lot moving forward. All right. Next one I want to do is number 7. So we skipped it, but I want to make sure we do this. Here's where you want to be really, really careful. So don't be this kid. All right, this drives us nuts. So if I gave you like 4x and I ask you to square that whole thing, notice how this is just one term. It's just one product. If that's the case, then we can go ahead and say that I'm going to square the 4 and get 16. I'm going to square my x and get an x squared. If I give you even more terms, x, y, and square it, notice how it's all one big product. We can go ahead and say this is 16, square the x, square the y. That's going to be your final answer. As soon as we throw a little plus sign in here and we're adding those, that's not how it's going to work. And the reason for that, so let me show you with some numbers, because my calculus kids will still do this as seniors. So don't be these people. Think about numbers here in order of operations. So let's say I do a 2 and a 3. And let's say I do, actually I'll use these numbers without the variable, 2 plus 5, and I want you to square that. Hopefully we all understand order of operations, and you would say I'm supposed to do inside the parentheses first. Then you're going to do your squared. So the right answer is 49. That is the correct answer that you would have been taught in 5th grade when you learned order of operations. Think about if you try to square each of those, though. If I say 2 squared is a 4, which it is, and then I think I can just add 5 squared, which is 25, is that going to give me a 49 like I'm supposed to get? No, it's going to give us a 29. This is wrong. When we have a sum here, we can't just square both of those terms. Okay? So what you want to do here, and there is a shortcut, but we're not going to show it now. Take an extra couple of seconds and then just rewrite this, and don't think you can just square each individual term. So all this really is like saying 3 squared. We could write that as a 3 times 3. It's the same thing with that quantity. Just write it twice. And then all we're really doing is something that we're pretty good at. We've been doing now. We did this a little bit last chapter. We can just now go through, do your distributing. So we'll get 2x and 2x equals 4x squared. The 2x and the 5 make a 10x. And then 5 and a 2 make a 10x. And then the 5 and the 5 make a 25. We have our like terms, 4x squared plus 20x plus 25, and then that's our answer. All right. All right, next ones. We can do 9, I'm pretty certain. The last new thing here, somewhat new, are 10 and 11. What we've been doing, so we've been taking binomials, multiplying them by another binomial. So if you think about what bicycle means, what that prefix bi means, it's 2. So that's why all of these had 1, 2 terms in the parentheses, and this was 1, 2 terms. The only thing different now is instead of doing a binomial times another binomial, notice how there is now, as you look at that, there are now 3 terms in that. So if we know the prefix that means 3, that would be a trinomial. So we're going to take our trinomial, multiply it by a binomial, and it's a very, very similar process. You're going to take this x squared, the first term in the trinomial, that needs to be distributed to each term in the second one. So you'll do x squared times x. So x squared times x should now give us an x cubed. And then the x squared has to get multiplied by the -3, which is a -3x squared. Once you were done with that, so now the x squared has been distributed, so I can kind of ignore him for a minute. I'm now going to take the 4x, and the 4x needs to be distributed. So the 4x multiplied by x would be a 4x to the power of 2. And then the 4x gets multiplied by the -3. So a -4x times a -3 should give us a -12x. We're now done with the 4x. So he's been distributed, but we still have the 5 that needs to be distributed. So now take your 5. The 5 times x would be a 5x. And then the 5 multiplied by the -3 is a -15. Now we got a bunch of like terms. So now we just go through, if we see any like terms, we want to put them together. Remember how we want to be in descending order. So now that we actually have a power of 3, that's got to be our first term when we write this. So we want x cubed to go first. Then we want our x squareds to go next. So we have an x squared here. It's a -3x squared. And we also have a positive 4x squared. Add those up. That should give us a positive 1x squared. So we're done with the cubes. We've added these together. Now we look for our x to the firsts. So here's an x to the first. Here's an x to the first. So we're going to combine those. A -12 plus a 5, -7x. So now we're done with these guys. We've combined those. And then we only still have the constant hanging out at the end. So he is just -15. All right. All right, last one, number 11. Go through that, same thing, trinomial by binomial. See if we can get through that completely, and we'll call it a day. All right, let's see where we're at. I'm going to do it the same way I just did in number 10, but I do want to just kind of show you some other thoughts. You could, if you want, take the 3 and distribute it in this direction. That's okay. So if you want to take the 2 terms on the right, distribute it to the 3 on the left, that's a viable option. And then you would just take your 8 and then make sure that gets distributed. So if you like doing the 2 to the 3, totally fine. I usually just do whichever one is first. So since our trinomial is first, that's the order that I'm going to take. So hopefully we did 4x and 3x to get a 12x cubed. The 4x squared and an 8 should give us a 32x squared. And then this guy's been distributed. All right, that one's done. So now we go to the negative 7. Negative 7x times a 3x is a negative 21. And then that should give us an x times an x, so x squared. And then the negative 7x and an 8 should give us a negative 56, and we would just have one x for that one. The negative 7 has now been distributed. So then from there, we're going to take our 2 and create a little space here. So now this 2 would just get distributed. The 2 and the 3x make a 6x, and then the 2 and the 8 would make a 16. We want this in descending order, so we want this to be our first term. That's the only cubed term. There were no like terms to combine that with. So this would start with the 12x cubed. And then we'll just keep track. So once I know I'm done with that one, I'll cross it out. Then we have an x squared here and an x squared here that we can combine these guys. So 32 take away a 21 is 11. So we have 11x squared terms. We're done with those. We then have a negative 56x and a positive 6x. We combine those being negative 50 x's. Done with those. And then our constant hanging out by himself, nobody to combine him with, is a 16. All right. Not particularly hard necessarily, but just a lot of places to make little mistakes with our powers or adding like terms, things like that. But that's a trinomial by a binomial. All right. So finally done. So you finally get homework. So it's underneath your assignments. Yeah, so 10-1 is tomorrow. So tomorrow by midnight, if you go here, you can find it. If you go to our module, you can also find it. But underneath our assignments, if we click on it, you can find it here. You can also find it in our module. It's also when you're ready, set, go packet, or your yeah. So you have that second packet. Let me show you what it looks like so you can see what this would look like when you get your packet. Hopefully. It should say 2.3 at the top. Ready, set, go. We're starting to slow down a little bit. And you're looking at these couple of problems to start. A couple parabolas, and then you're going to start to see these little square things, what we've been doing here for the last 3 days. All right. All right. With that, we're less than a minute. There's no bells today, so I got to keep a little better eye on the clock, but we're inside of a minute. So you're free to go. All right. Have a good day, and we'll see you guys all back tomorrow. All right. We'll see some of you in school tomorrow, too. All right. What's that, Cam?